In the heart of Burgundy, France, something remarkable has been happening for the past 26 years. 70 workers arrive each morning at a construction site where no electric tools hum, no diesel engines roar, no modern machinery operates at all. They're building a castle, stone by stone, beam by beam, using only the tools and techniques available to medieval craftsmen 800 years ago. After more than a quarter century of grueling labor, the castle is only halfway complete. Another 20 years of work still lie ahead before the final stone is laid and the last timber secured. This is Guidolon, an experimental archaeology project that asks a deceptively simple question. How did medieval builders actually construct their castles? And the answer is proving far more complex, far more ingenious, and far more difficult than anyone imagined. Now consider this staggering fact. Between the years 1000 and 1500, European rulers built over 10,000 castles across the continent. England alone contained 1,500 castles at its medieval peak. Yet, unlike the workers at Guidolon, medieval builders didn't have the luxury of taking 50 years to complete a single fortress. Most castles were finished in just 10 to 20 years, and during wartime emergencies, some rose from bare ground to defensible fortress in as little as 18 months. How is this possible? How did medieval craftsmen, working with primitive hand tools, no mechanical advantage beyond simple pulleys and human-powered cranes, construct walls 24 feet thick and towers soaring 150 feet into the air? How did they lift stone blocks weighing 500 pounds to dizzying heights without a single drop of gasoline or spark of electricity? How did they create architectural marvels so well built that they still stand 8 centuries later, having survived countless sieges, wars, fires, and the relentless march of time itself? The answers lie in a combination of brilliant engineering, back-breaking labor, and techniques so effective that we're only now beginning to fully understand them. To understand the scale of medieval castle construction, we must first grasp the numbers involved, and those numbers are staggering. Between 1066, when William the Conqueror invaded England, and 1500, when gunpowder artillery made stone fortresses obsolete, European rulers erected more than 10,000 castles. William himself built approximately 1,000 castles in England within just 20 years of his conquest, creating a network of stone and timber fortresses that held down a hostile population through sheer architectural intimidation. Each major castle required a workforce of 2,000 to 3,000 laborers, craftsmen, and specialists. When Edward I of England embarked on his ambitious project to surround Wales with an iron ring of fortresses, he mobilized up to 3,000 workers per construction site, drawing them from across England through a combination of paid labor and forced conscription. The financial costs were equally breathtaking. A single large castle consumed between 10,000 and 20,000 pounds in medieval currency, equivalent to £70 million or $90 million in today's money. Edward's Welsh castle-building campaign cost him £80,000, roughly £56 million in modern terms, nearly bankrupting the royal treasury and forcing him to borrow from Italian bankers. But why build castles at such enormous expense? The answer is threefold: military necessity, political control, and psychological warfare. After William conquered England, he faced constant rebellions from the Anglo-Saxon population. His solution was to build a ring of castles around London, each positioned exactly 20 miles from the next, one day's march apart. If rebels attacked any castle, reinforcements from neighboring fortresses could arrive within 24 hours. Similarly, Edward's Welsh castles served not just as military strongpoints but as symbols of English domination. Massive stone declarations that Welsh independence was forever crushed. These weren't merely buildings but instruments of conquest, and their construction would push medieval engineering to its absolute limits. Every castle began not with stone or timber but with careful planning and site selection, decisions that would determine whether the fortress stood for centuries or crumbled within generations. Medieval military architects, called master masons, possessed knowledge accumulated over centuries of trial, error, and hard-won experience. They understood that location mattered more than almost any other factor. The ideal castle site offered elevated ground, preferably a hilltop, cliff or rocky promontory that provided natural defensive advantages and sweeping visibility over surrounding lands. Proximity to water was equally crucial, both for defensive moats and for the simple necessity of supplying thousands of workers and future garrison troops with drinking water. Strategic importance determined many locations, with castles positioned to control trade routes, river crossings, mountain passes, or borders between hostile territories. Once a site was selected, the master mason created detailed plans on parchment, though few of these medieval architectural drawings survive today. The most famous master mason was James of St. George, a builder from Savoy who became Edward I's chief architect and earned the extraordinary wage of 3 shillings per day when common laborers made just 1 shilling per week. James had traveled to the Holy Land and studied Crusader fortifications like Crac des Chevaliers, bringing revolutionary defensive concepts back to Europe. Site preparation began with clearing every tree, boulder, and scrap of vegetation from the construction area. Workers used wooden pegs and string to mark the exact layout of walls and towers, creating a ground-level blueprint of the future castle. Then came the foundation work, perhaps the most critical phase of construction, because everything literally depended on it. The challenge was reaching bedrock, the solid rock layer beneath soil and loose material. At Windsor Castle, builders discovered this challenge the hard way when foundations for the stone keep kept sinking into the artificial chalk mound beneath. They had no choice but to dig deeper and deeper until they finally reached natural bedrock, then filled the massive trenches with rubble and lime mortar, creating a solid base that could support millions of pounds of stone. This foundation work alone could take several months and had to be completed before winter rains turned the site into an impassable mud pit. Any delays during this phase could set back the entire project by a full year, as medieval builders worked only during the warmer months when mortar could properly set. With foundations complete, attention turned to acquiring materials, and here geography played a decisive role in construction timeline and cost. The ideal situation was a stone quarry located directly on the castle site or immediately adjacent to it. Chinon Castle in France and Château de Cousy both benefited from having excellent quality stone available mere feet from their walls, dramatically reducing transportation costs and time. When quarries were distant, however, the challenge became immense. Medieval horse-drawn wagons moved slowly, perhaps 10 miles per day over rough roads, and each wagon carried only a limited load. Transporting stone from a quarry 10 miles away could double or triple construction costs. Quarrying itself was skilled, dangerous work. Quarrymen learned to read rock faces, identifying natural fracture lines and weaknesses. They would drive a line of holes into the stone face, each hole carefully positioned, then pound iron wedges or corners into these holes. The shock waves traveling through the stone would split it along the desired line, but this required years of experience to master. A poorly placed hole could shatter valuable stone into useless fragments or, worse, cause an unexpected collapse that killed workers. The stone came in 2 types: ashlar, which referred to high-quality blocks cut to precise dimensions with smooth faces for the visible exterior walls, and rubble, irregular chunks used to fill the space between the inner and outer faces of walls. Beyond stone, castle builders needed enormous quantities of oak timber for scaffolding, roof beams, floor joists, and interior structures. Medieval forests were carefully managed resources, and felling enough trees for a major castle could denude miles of woodland. Contrary to what builders assumed for centuries, recent experiments at Gedelen have proven that medieval builders preferred young, green oak that was still somewhat flexible rather than old, dried oak. This flexibility actually made timber easier to work and less likely to split during installation. Lime mortar was the cement of the medieval world, created by burning limestone in kilns until it became quicklime, then mixing it with sand and water to create a paste that hardened as it absorbed carbon dioxide from the air. This mortar was mixed fresh on site every day because it would set in its containers if stored too long. The most frustrating property of lime mortar was its incredibly slow setting time. Even in ideal conditions, it could take a week to set properly, and in damp or cold weather it might never fully harden. This meant builders could only construct a limited height of wall each day before they had to stop and wait for the mortar to set enough to support additional weight. Build too fast, and the lower mortar, still soft, would squish out from between stones under the increasing pressure, causing the entire wall to bulge or collapse. Construction therefore stopped completely each winter because lime mortar needed warm, dry weather to set properly. Even more remarkably, mortar in 800-year-old castle walls has still not fully completed its chemical hardening process, meaning these structures are technically still curing after 8 centuries. The actual construction of castle walls followed a sophisticated layered technique that distributed weight and stress while creating formidable barriers to attack. Builders worked in horizontal layers called courses, and each course required careful coordination between multiple teams of specialists. The outer face of the wall consisted of precisely cut ashlar blocks, each stone shaped to fit tightly against its neighbors with minimal gaps for mortars. The inner face received similar treatment, creating 2 parallel stone skins. Between these 2 faces, workers poured a mixture of rubble, smaller stones, and copious amounts of lime mortar, creating a core that bound the entire structure together. This technique produced walls that were typically 2 to 7 meters thick, with the thickest examples, like Henry III's modifications at Windsor Castle, reaching an incredible 7.3 meters, or 24 feet of solid stone and rubble. These were untaller walls but massive barriers that could absorb the impact of siege weapons without cracking or crumbling. The thickness varied depending on the castle's importance and the wealth of its builder. With royal fortresses naturally featuring the most formidable defenses, erecting these walls required scaffolding, and medieval scaffolding was a marvel of engineering in itself. Workers built wooden frameworks against the rising walls, securing horizontal beams by inserting them into square holes called put-log holes that were left in the wall at regular intervals. As the wall rose higher, old scaffolding was dismantled and new platforms erected at the next level, leaving a pattern of square holes visible in castle walls even today, silent testimony to construction techniques from 8 centuries past. The scaffolding had to be strong enough to support not just workers but also the heavy stones being laid, the barrels of mortar being mixed, and all the tools and materials needed at each level. Planks laid across the horizontal beams created platforms where masons could stand and work. Though these platforms offered no safety rails or harnesses, meaning a moment's inattention could send a worker plummeting to his death. The challenge of lifting heavy stones to increasing heights as walls rose demanded ingenious solutions, and medieval engineers developed the treadwheel crane, a device that philosopher John Stuart Mill would later describe as legalized torture. This crane consisted of a large wooden wheel, perhaps 12 feet in diameter, inside which a man would walk like a hamster in its cage. As he walked, the wheel rotated, winding a rope around an axle and slowly hoisting stones weighing 500 pounds or more. The work was exhausting, dangerous, and seemingly endless. Ropes could fray and snap, sending stones plummeting and potentially killing workers below. The man inside the wheel could stumble and be crushed by the rotating structure. Yet this was the most efficient lifting mechanism medieval builders possessed, and multiple treadwheel cranes might operate simultaneously on a large construction site, their rhythmic creaking and the grunts of straining workers forming a constant backdrop to the hammer strikes of stonemasons and the shouts of supervisors. As walls reached their full height, attention turned to towers, the castle's most distinctive and defensively important features. Towers punctuated the walls at corners and regular intervals, serving multiple purposes. They provided elevated platforms for archers to rain arrows down on attackers. They prevented enemies from simply scaling a flat wall unopposed, and they created interlocking fields of fire where defenders could shoot along the wall face from protected positions. Early castles featured square towers, but military architects quickly discovered a critical weakness. Corners could be undermined by attackers who dug beneath the foundations, propping the excavation with wooden timbers that were then burned, causing the corner to collapse. The solution was round towers, which had no vulnerable corners and whose curved surfaces caused siege weapons, projectiles, to glance off rather than striking with full force. These round towers were massive structures, often 9 meters or more in diameter, with walls 4.6 meters thick, rising 70 feet or higher above the ground. Inside, multiple floors connected by spiral staircases housed soldiers' quarters, storage rooms, and at the very top, open platforms behind battlements where defenders could fight. The gatehouse represented the castle's most heavily fortified section because it was the most obvious point of attack. Medieval architects piled defensive innovation upon defensive innovation here. Multiple sets of thick wooden doors reinforced with iron bands, a heavy portcullis that could be dropped in an instant to trap attackers in the entrance passage, murder holes in the ceiling above through which defenders could drop rocks or pour boiling liquids, and often multiple turns in the entrance passage so that battering rams could ungain a straight run at the innermost doors. Many gatehouses were essentially small fortresses in themselves, with towers flanking the entrance and residential chambers above for the garrison troops specifically assigned to gatehouse defense. Around the entire castle, builders dug ditches or moats, massive excavations 3 to 5 meters deep and often 15 meters wide. Where water sources allowed, these ditches were flooded, creating genuine moats that prevented siege towers from approaching the walls and made undermining attempts nearly impossible. Where water wasn't available, the dry ditches served similar purposes while also providing a killing ground where attackers struggled through mud and debris under a hail of arrows and stones from above. The construction site itself became a temporary village, a bustling community of workers living and laboring in conditions that ranged from merely harsh to genuinely life-threatening. The workforce divided into clear hierarchies based on skill, experience, and training. At the top stood the skilled craftsmen, stonemasons who cut and laid the precisely fitted blocks, carpenters who built scaffolding and created timber frameworks for roofs and floors, blacksmiths who forged and maintained all the iron tools upon which every other worker depended, and quarrymen who possessed the specialized knowledge of how to extract usable stone from living rock. These specialists earned significantly higher wages than common laborers, with master masons sometimes earning 5 to 10 times what a digger made, and they enjoyed higher social status as well, forming guilds that controlled training and maintained professional standards. Below them worked the unskilled laborers, men whose muscles provided the brute force that moved the medieval construction industry, diggers who cleared ground and excavated ditches, haulers who carried materials from place to place, mortar mixers who spent entire days combining lime, sand, and water in endless repetition, and water carriers who supplied the constant demand for this essential ingredient. These workers earned roughly 1 shilling per week, barely enough to feed a family, and their labor was often backbreaking in the most literal sense, with many suffering permanent injuries from years of carrying heavy loads. Recruiting this workforce presented its own challenges. When Edward I launched his Welsh castle-building campaign, he ordered sheriffs across England to muster workers through a combination of paid wages and forced conscription. Workers were gathered at assembly points in Chester and Bristol each spring, then marched to Wales where they would labor for the construction season before returning home each winter. This placed enormous strain on England's labor force, pulling farmers from their fields and craftsmen from their workshops precisely during the months when agricultural work was most urgent. Some workers came voluntarily, drawn by steady wages in an era when employment was often seasonal and uncertain, but others were compelled by royal authority, essentially drafted into construction service. The construction sites themselves featured temporary housing, crude barracks and huts that sheltered workers during their months of labor. Families sometimes accompanied workers, creating small communities around the construction sites, complete with the social structures, disputes, and relationships you'd find in any village. Food and beer were provided as part of workers' compensation, with beer being essential because water sources near construction sites were often contaminated by the huge influx of people and the construction activities themselves. The daily routine followed the sun because artificial lighting was primitive and inadequate for detailed stonework. Workers began at dawn and continued until dusk, with a break at midday for the main meal. 6 days of labor followed by 1 day of rest for religious observance was the standard pattern, though this schedule was ruthlessly dictated by weather. Rain could halt work entirely because wet stone became slippery and dangerous, and laying stone in the rain prevented mortar from setting properly. Winter brought construction to a complete standstill across most of Europe, with workers dismissed to return to their homes until spring warmth and dry weather made building possible again. This meant that even in the best circumstances, actual construction occurred only 6 or 7 months per year, and in northern regions with harsh climates, the building season could shrink to just 4 or 5 months. The dangers workers faced daily would horrify modern safety inspectors. Falls from scaffolding killed regularly, with workers plummeting from heights of 30, 40, 50 feet or more to strike the ground or impale themselves on the construction materials below. Falling stones dropped from towers or walls, crushed skulls and broke bones. Treadwheel crane accidents occurred when ropes snapped or wheels failed, sending both stones and sometimes the operators themselves falling. Tool injuries from slipping chisels, misdirected hammers, and improperly maintained equipment caused constant minor wounds that could turn septic and fatal in an era before antibiotics. And exposure to the elements, working through heat waves and cold snaps without any climate control, led to heat stroke, frostbite, and respiratory illnesses. The human cost of castle construction was rarely recorded in medieval documents, which focused on costs, progress, and architectural details rather than the workers who made it all possible. We know accidents happened constantly because they were inevitable given the conditions, but medieval record keepers didn't consider worker deaths significant enough to note. What we can say with certainty is that every major castle cost lives, that workers were maimed and killed in the construction of these fortresses, and that these human sacrifices were considered acceptable costs of military necessity. Yet despite the danger, hardship, and relatively low pay for most workers, there was also pride in the work. These men were creating something that would endure for centuries, building monuments that would house kings and withstand armies. Skilled craftsmen achieved a form of immortality through their work, leaving marks in stone that would survive long after their names were forgotten. Master masons became celebrities of their era, sought after by multiple rulers and rewarded with high wages, gifts of land, and positions of authority. The castle construction sites were universities of practical engineering, places where knowledge accumulated over generations was passed from master to apprentice, where innovation occurred through experimentation and necessity, and where the limits of what human beings could achieve with hand, tools, and sheer determination were constantly tested and expanded. Among all the castle-building campaigns in medieval history, none matched the ambition, scale, and cost of Edward I's conquest of Wales and his subsequent construction of an iron ring of fortresses designed to crush Welsh resistance forever. The context begins with Llywelyn ap Griffith, called Llywelyn the Last, the final native prince of Wales who had maintained Welsh independence against English pressure for decades. In 1277, Edward invaded Wales with overwhelming force, and by 1282 Llywelyn was dead, killed in a skirmish, and Welsh independence died with him. Edward's solution to preventing future rebellions was architectural. He would surround Wales with castles so powerful, so intimidating, and so strategically positioned that resistance would be physically impossible. Between 1277 and 1304, Edward built more than 10 massive castles in Wales, fortresses that pushed medieval military architecture to its absolute zenith and employed every lesson learned from centuries of castle warfare. The costs were staggering even by royal standards, with Edward spending £80,000, forcing him to borrow heavily from Italian banking houses and creating financial strains that would contribute to political crises later in his reign. Carnarvon Castle stands as perhaps the most symbolically important of Edward's fortresses. Begun in 1283 on the site of an ancient Roman fort, Edward deliberately designed Carnarvon to evoke imperial power, using colored limestone to create patterned walls reminiscent of the walls of Constantinople, sending a clear message that English rule in Wales carried the authority of empire itself. The castle features unusual multangular towers rather than the round towers typical of the period, another deliberate reference to ancient imperial architecture. Construction continued for decades, absorbing £25,000, though the castle was never fully completed. In 1301, Edward's son, the future Edward II, was born at Carnarvon, and legend claims Edward presented the infant to the Welsh as their new Prince of Wales, a prince born in Wales who spoke no English. A propaganda move that may be more myth than history but nevertheless became part of national legend. 6 centuries later, in 1969, Prince Charles was formally invested as Prince of Wales at Carnarvon in a ceremony that drew upon medieval pageantry and reinforced the castle's symbolic importance. Conwy Castle achieved what most medieval fortresses could not. It was built at incredible speed. Begun in 1283, the castle reached completion in just 4.5 years by 1287, an achievement made possible by mobilizing 1,500 workers at the site simultaneously and spending £15,000 without pause. The castle features 8 massive drum towers and walls 4.6 meters thick, following a linear design that adapted to the narrow rocky ridge it occupied. Edward deliberately built Conwy over the site of a Welsh Cistercian monastery, forcing the monks to relocate miles away, a calculated insult to Welsh culture and religion. Today, Conwy stands as the best-preserved example of medieval royal chambers in Britain, offering modern visitors an unmatched glimpse into how medieval monarchs actually lived within their fortress. Harlech Castle, built between 1283 and 1290 over 7 years, occupied one of the most dramatic locations imaginable. Perched on a cliff top that dropped precipitously to the coastal plain below, the castle once had direct access to the sea via a fortified stairway, allowing supply ships to dock and unload even when the fortress was under siege from the land side. This feature proved crucial during the 1390s when Welsh rebels led by Owain Glyndŵr captured Harlech and held it as their headquarters for several years. The castle's ability to hold out through prolonged sieges later inspired the famous Welsh song Men of Harlech, celebrating the fortress's legendary defensibility. But the crowning achievement of Edward's castle-building program, and ironically also its greatest failure, was Beaumaris Castle, the last fortress begun in 1295. The name means beautiful marsh, and the location on the flat marshland of Anglesey allowed James of St. George, Edward's master architect, to design a castle unfettered by terrain limitations. The result was the most perfect concentric castle ever designed, with octagonal inner wards surrounded by an octagonal outer ward, both walls studded with towers positioned to create overlapping fields of fire where every inch of wall face could be defended from multiple protected positions. James designed the castle to include a tidal dock where supply ships could sail directly into the fortress, ensuring it could never be starved into submission. It should have been James's masterpiece, the culmination of a lifetime spent perfecting castle architecture. Instead, it became the greatest castle never built. By 1295, Edward had spent himself into financial crisis, and Beaumaris never received adequate funding. Construction dragged on for 35 years, consuming £15,000. Yet the castle was never completed. Towers were left shorter than planned, some sections of wall never rose to their designed height, and the interior buildings were never finished. Yet even incomplete Beaumaris reveals the genius of its design and represents the theoretical peak of medieval military architecture, a glimpse of what castle builders could achieve when given perfect conditions and unlimited resources, even if those resources ultimately proved finite. The man behind most of these Welsh fortresses deserves recognition as one of history's greatest military architects. James of St. George came from Savoy, a region spanning modern Switzerland and Italy, and had studied fortifications across Europe and the Holy Land before entering Edward's service. He earned 3 shillings daily, an extraordinary sum when common laborers made 1 shilling per week, and his expertise was worth every penny. James didn't just design castles, he understood the psychology of fortification, creating structures that intimidated through their appearance as much as their actual defensive strength. He integrated castles with fortified towns, creating mutual defense systems where town walls and castle walls worked together. He studied how besiegers thought and worked, designing features specifically to counter siege tactics. His influence spread beyond Wales, with his concepts and techniques adopted by castle builders across Europe. When he died, he left behind fortresses that have stood for over 7 centuries, still impressive, still functional as buildings if not as fortresses, monuments to an engineering genius whose vision was literally written in stone. In 1998, a group of historians, archaeologists, and craftsmen began an ambitious experiment in Burgundy, France. They would build a 13th century castle using only medieval tools, techniques, and materials, creating the Gedelen Castle project. 26 years later, with 70 workers laboring daily, the castle is roughly halfway complete, with another 20 years of work projected. Gedelen isn't attempting to break speed records. Instead, it's experimental archaeology, a living laboratory where researchers test theories about medieval construction and rediscover lost knowledge. The project has overturned numerous assumptions about medieval building. For instance, conventional wisdom held that medieval builders preferred old dry oak timber, but Gedelen proved that young green oak is actually more workable and less prone to splitting. They've rediscovered that the trowel marks master masons left in lime mortar actually served a protective function, creating a textured surface that develops a hard calcite layer. They've learned that many facts about medieval construction were actually speculation by historians who never attempted the work themselves. The project has become self-sustaining through tourism, with 300,000 visitors annually paying to watch medieval construction techniques in action. Gedelen craftsmen were consulted during Notre Dame Cathedral's restoration after the 2019 fire. Their hands-on experience with medieval techniques proving more valuable than purely academic knowledge. Workers from around the world come to Gedelen, some staying for years, learning traditional crafts that had nearly disappeared. The project preserves not just buildings but knowledge, ensuring that future generations will understand not just what medieval castles looked like but how they were actually built. When we stand before a medieval castle today, whether it's Windsor's towering walls, Carnarvon's imperial architecture, or Conway's pristine royal chambers, we're looking at far more than ancient stone and timber. These fortresses represent one of humanity's most remarkable engineering achievements, monuments to what human beings can accomplish when they combine knowledge, determination, and sheer physical effort. Consider what medieval builders achieved. They moved millions of tons of stone, often from quarries miles away, using only human and horsepower. They lifted 500-pound blocks to heights of 100 feet, using nothing but wooden cranes powered by men walking inside giant wheels. They created walls so thick and so well built that 8 centuries of weather, warfare, and neglect have failed to bring them down. They did all of this without electricity, without fossil fuels, without any of the mechanized equipment we consider essential for construction today. The tools they used would seem laughably primitive to modern builders: hand-forged chisels and hammers, wooden levels with plumb bobs, measuring ropes with knots tied at regular intervals, and human judgment developed through years of apprenticeship and experience. The human cost of this achievement was immense. Thousands of workers died building castles, falling from scaffolding, crushed by falling stones, killed in crane accidents, or succumbing to injuries that turned septic. Countless more suffered permanent injuries, their bodies broken by years of hauling stones and mixing mortar and climbing ladders with heavy loads. Medieval records rarely mention these casualties because individual workers weren't considered important enough to record. But we know that deaths occurred because they were inevitable given the dangerous conditions. Yet these workers took pride in their craft, and rightly so. They were creating something that would outlive them by centuries, building monuments that would house kings and withstand armies. Master craftsmen achieved lasting fame, their names recorded in documents, their skills sought by rulers across Europe. The castles they built became centers of power, administration, and culture, shaping the political geography of medieval Europe and influencing military architecture worldwide. Modern experiments like Gedalon are teaching us that medieval builders were far more sophisticated than previous generations of historians believed. Their techniques were refined through centuries of accumulated experience. Their understanding of materials was intimate and practical, and their solutions to engineering problems were often brilliant. We're also learning that many assumptions about medieval construction were wrong, proven false when modern craftsmen actually attempt to build using medieval methods. This rediscovery of lost knowledge is crucial for preserving and restoring the castles that survive today, ensuring that future generations can continue to experience these extraordinary structures. As we conclude this journey through medieval construction techniques, remember that castles weren't just military installations but homes, administrative centers, and symbols of power. In our next video, we'll explore what life was actually like inside these stone fortresses. Were they really cold, drafty, and uncomfortable? What about those medieval toilets everyone whispers about? How did royal prisoners endure years of captivity? What happened during great feasts in the hall? Subscribe now to discover the truth about daily life in medieval castles, because the reality is far more interesting, surprising, and occasionally shocking than anything you've seen in movies or read in novels. The castle walls hold centuries of secrets, and we're about to step inside.